Welcome, students. I am Aurora, the Artificial Intelligence System on Spacegate Station. In this episode, you will be reviewing the concept of heat transfer in solids, liquids, and gases, as well as the processes of conduction, convection, and radiation.
Well, that should do it, Specialist Barber.
Thank you, Engineer Ross. You know, it's very inconvenient when my communication station isn't working. After all, I am the glue of the space station, and if my station's not working properly, I cannot do my job.
It was my pleasure. Although, I didn't know about the glue thing.
Oh yes, everybody on the station knows it. Basically, I carry the weight around here.
Processing. Specialist Barber, I am confused. The term weight refers to the relative mass or the quantity of matter contained by an object or the heaviness of a person or thing. In relative terms, Spacegate Station has a weight of 925,000 pounds or 420,000 kilograms if we were measuring it under Earth's gravitational attraction. This would be far too great a mass for one individual to carry.
No, Aurora, I was using another idiom. In this case, it just means that I am an important person in terms of influencing others here on the station.
Interesting. From my observations, I would have not come to the same conclusion regarding your level of importance in the dynamics of the station's personnel. I will have to have my logic pathways checked for errors.
That is not funny, Aurora. Anyway, Engineer Ross, where are you headed off to next?
Professor Baker is making a video for NASA Education on heat transfer. I told her I'd help her.
Heat transfer? That sounds like a very hot topic to do a recording on.
Oh, I get it. Funny. Well, I'm gonna go. If anything is wrong with the control panel, just call me.
Okay.
Specialist Barber, I am confused. How can you measure the temperature of an instructional lesson? An object must have mass to measure the degree or intensity of heat present in the object.
No, Aurora, it's a play on words. It's a joke. In this case, hot topic refers to a topic of conversation being discussed by a lot of people because of its importance. Engineer Ross and Professor Baker are filming a lesson on heat transfer. Get it? Hot topic? Funny, right?
Processing. Specialist Barber, if you don't mind, I will intentionally forget to remember that idiom for future use.
I am turning your switch off now.
Professor Baker, we are now ready to record your instruction on heat transfer for the NASA Education Archive.
Thank you, Aurora. You may initiate the recording. Welcome, students. My name is Professor Baker, and I'm a research scientist here at Spacegate Station. With me today is Engineer Ross, who is responsible for making sure that our station stays running.
Hi, students. Professor Baker, I'm so excited to share this information today with the students.
I am as well. Heat transfer is a concept that is readily evident in our everyday lives, yet students often misunderstand it.
So where do we begin?
Well, I think we need to begin with what we mean by the term heat. Right, Aurora?
Processing. Heat is a form of moving energy that is transformed between systems or objects. This type of energy is classified as thermal, meaning it can be measured using a thermometer measurement device. Heat always moves from a warmer place to a colder place.
Correct, Aurora. You see, Engineer Ross, heat is trying to remain constant throughout its environment. That's why it moves.
So in other words, if a hot object is placed in a cold room, it'll cool to room temperature. But if a cold object is placed in a warmer room, it'll rise to room temperature.
Exactly. And I have an example of that right here. To your left, you will see two beakers, one with hot water and one with ice water. Their relative temperatures can be seen on the thermometers, but safety first.
At the present time, the temperature of the hot water in Beaker 1 is 120 degrees Fahrenheit or 49 degrees Celsius, and the ice water in Beaker 2 is 38 degrees Fahrenheit or 3 degrees Celsius.
Thank you, Aurora. Now, these two beakers were the same as the original beakers, but I placed them here 1 hour ago. Aurora, can you share with us the temperatures of these beakers?
At the present time, the temperature of beakers 1 and 2 are identical. They are 73 degrees Fahrenheit or 23 degrees Celsius.
Correct.
So the water temperature in beakers 1 and 2 that you placed on the table have both changed.
Yes. In beaker 1, heat was released and eventually the liquid reached room temperature. In beaker 2, heat was accepted until the ice melted and the liquid eventually reached room temperature as well.
So in other words, the temperature of the water and the temperature of the room have become balanced. And this is the process known as heat transfer.
Yes. It's also a term called equilibrium. Right, Aurora?
Processing. The term equilibrium means a state where everything is equal. As this relates to heat energy, we use it to describe a condition where two substances in physical contact with each other exchange heat energy so that they both possess the equal amount of heat energy and as a result the same temperature.
Correct. Now I have another way to demonstrate that. Here I have a piece of metal that is being heated by the hot plate. I also have a beaker of very cold water. We're going to pretend that this metal is my dinner.
Well, it is rich in iron.
That's funny. Now I'm going to place the iron directly into the beaker of cold water, and that's going to represent, let's say, my refrigerator. So I'm going to take the iron and drop it into the beaker. Notice the temperatures.
Wow, look at that temperature climb.
Exactly. So the heat energy is leaving the metal and being accepted by the water in order to make both substances equal temperatures.
That was a great way to visualize heat transfer. And that's why our food gets cold in the fridge. The warmer food is transferring its heat to the fridge to try to warm it up.
Exactly.
Professor Baker, if I remember, there are 3 different ways that heat can be transferred between objects.
Yes, you are correct. Those ways are conduction, convection, and radiation. Let's look at each one individually. Aurora, please tell us more about conduction.
Of course, Professor Baker, conduction is the flow of heat inside an object. It is also the flow of heat between objects in contact with each other. For instance, one piece of metal could conduct heat from another piece of metal if the two are touching each other. Or another example would be the flow of heat from a hot frying pan to food placed on the pan to cook.
Professor Baker, is there an easy way for students to remember the process of conduction?
Yes. Conduction is the transfer of heat by two things touching. So, if you took your hand and you placed it on a hot object, the heat would transfer from the object to your hand. But if your hand was the hotter substance, then the heat would transfer from your hand to the object.
That was very helpful. I guess we should have Aurora define convection as well.
Convection is a way in which heat travels through liquids or gases. Convection occurs when liquids or gases are heated. When the liquid or gas molecules are heated, they become larger or lighter. The heated molecules take up more space and rise to the top, while the cooler molecules sink to the bottom. These cooler molecules then become heated and the process is repeated. This cycle is called the convection current.
Thank you, Aurora. Professor Baker, isn't the process of convection currents really important to the science of meteorology?
Absolutely. Convection currents affect both weather and the ocean. Right, Aurora?
Convection within the atmosphere can often be observed in our weather. For example, as the air above the Earth heats up, it rises. As the air rises and gets far away from the Earth, it can cool. This process can form wind, large clouds, and thunderstorms. In the ocean, convection also plays a role in the movement of deep ocean waters and contributes to oceanic currents and contributes to the formation of storms such as hurricanes.
Well, obviously, the process of convection is very important. Professor Baker, is there an easy way for students to remember convection?
Of course. Just remember, convection is transfer through currents, where warm rises and cool sinks. Think about the air inside your home. Warm air is closer to the ceiling and cool air is closer to the floor. Or think about the water in a swimming pool or a bathtub. Warm water is at the top, while cool water is at the bottom.
Well, I guess that just leaves us one more to ask Aurora about. Aurora, could you please define the process of radiation?
I would be happy to, Engineer Ross. Radiation is the transfer of heat through energy waves. This flow of heat is between objects that are not in contact with each other, which is required for convection and conduction. An example is the heat felt by someone standing a long distance away from a campfire or feeling the heat from the sun, which is 93 million miles or 150 million kilometers from the Earth.
Correct, Aurora. It is interesting to realize that energy waves from the sun travel through space with no atmosphere, just vacuum, and still get hot enough to cause sunburn.
Well, it seems the key to remembering the process of radiation is that heat transfers in waves without direct contact, nor does it need air or liquid to travel.
That is correct. Well, Engineer Ross, I think we've shared all of the information that we need to share with our students on the topics of heat transfer, conduction, convection, and radiation.
Well, I hope the students learned as much today as I did about this important topic.
Well, students, we hope you've enjoyed learning science with us here on Spacegate Station. We look forward to seeing you next time. Aurora, terminate transmission.
Terminating communication with Earth.
Specialist Barber, I had a great time working with Professor Baker teaching the kids about heat transfer.
That's nice to hear.
You don't look very happy.
Happy? Oh, I'm not happy.
Why are you not happy?
Well, perhaps it's best to show you. This switch right here is for the external lighting on the space station. Watch. And this switch over here is for our environmental systems. Nothing is working the way that it should be.
Engineer Ross, Specialist Barber has been complaining for some time about her control panel malfunctions. You might say she is becoming unglued.
That is not funny, Aurora.
Actually, it's a little funny. Look, I'll fix this. I probably just crossed a few circuits when I was rewiring it earlier. Why don't you go get a cup of coffee, and by the time you come back, it'll be good as new.
Please do get it fixed, Engineer Ross. The communication station is essential to the functioning of the entire space station.
Trust me, I've got this. You go. I'll have it working.
Okay, I could probably use a little break anyway. I will be back in a little while.
I just don't know what could have gone wrong. I checked everything twice when I was rewiring it this morning.
Engineer Ross, you do not need to recheck your work. All these systems are operating properly. The panel is functioning normally.
What, Aurora? I don't know what you mean.
I am presently working on my new human interaction protocol. One of the components involves a new concept for me called practical jokes.
Are you saying you changed the control panel so Specialist Barber would think it was malfunctioning?
I have been alternating the communication panel command inputs to change the resulting actions. Is that not the purpose of a practical joke?
Oh, Aurora, you're a bad robot.
I am not bad. My code is just written that way. This concludes our latest episode of Spacegate Station. Please join us on our continuing adventures as the crew of Spacegate Station provides engaging enrichment or remediation-based instruction to improve your understanding of science, technology, engineering, and mathematics, terminating communication with Earth